Good morning. Thank you all for coming to the Connection Series. This Connection Series is jointly sponsored by the School of Engineering and Applied Science, and I'm Dean Ralph Catrano of the school, as well as the School of Arts and Sciences. We have a number of these Connection Series through the year, and if this is your first one, stay tuned. There's many more of great interest to all of us. Today, Colonel Robert Behnken, Chief of the Astronaut Office at NASA and Washington University alumnus, is here to talk to us about that title, The Future of NASA and the Astronaut Program. Bob is originally from St. Louis. Graduating from Pattonville High School in Maryland Heights, Bob came to Washington University as an Air Force ROTC student, receiving a bachelor's in science in both mechanical engineering and physics. We think it's mechanical engineering is why he came to Washington University. I know there's some physicists in the audience, but anyway. He went on to receive his master's and PhD at Caltech in 93 and 97, respectively. And during his first 2 years of graduate study, Bob developed control algorithms and hardware for flexible robotic manipulations. After graduate school, Bob was assigned to Elgin Air Force Base in Florida, where he worked as a technical manager and developmental engineer for the munitions systems. He was next assigned to attend the Air Force Test Pilot School at Edwards Air Force Base. After graduating, he was assigned to the F-22 Combined Test Force at Edwards, where he served as the lead flight test engineer for the 4th F-22. He was selected as mission specialist by NASA in July 2000. Following the completion of 18 months of training and evaluation, he was assigned technical duties in the astronaut office, Space Shuttle branch supporting launch and landing activities at Kennedy Space Center in Florida. During the fall of 2008, Bob trained as a mission specialist for STS-400. Google says that's the transport system, the space station transport system, STS. We got to get into the little logos here. The launch on need rescue flight for the last Hubble servicing mission. Since then, within the astronaut office, he has served as the exploration branch's chief of the Space Station Operations Branch and as Deputy Chief for Space Station Operations. Bob has logged more than 1,300 flight hours in more than 25 different types of aircraft. He flew on board shuttle missions STS-123 in March of 2008 and STS-130 in February 2010, logging more than 708 hours in space, including more than 37 hours during 6 spacewalks. He currently resides in Houston with his wife, fellow astronaut Megan MacArthur. We are honored to have him today with us. He's in town to receive the Alumni Achievement Award by the university tomorrow night at Founders Day, an award that is extremely well-deserved and one in which I think he really epitomizes what many of our alumni do. So it's really my great pleasure to introduce Bob Behnken and for him to give his lecture this morning. Bob?
Well, thank you for those kind words, and I hope I can continue to be a role model or at least an example of what Washington University alumni can do. So with that, I'll go ahead and get started here. I'm not going to stand behind the podium. I'll just jump ahead and start going through my slides here. I'm going to talk a little bit about the future of NASA's astronaut program. I know folks that have seen me give one of these presentations before. It's often been a video of a shuttle launching into space and that sort of thing. And I've got some pictures of that towards the end. But I wanted to give you guys a focus of what we actually do at NASA right now with our astronaut office. And historically, that's a little bit better. It's good now? Okay. Excellent. Sorry about that. So I wanted to give you a little bit of a focus of how we've switched gears a little bit at NASA. Y'all probably are familiar with the space shuttles launching folks into space. We're doing things a little bit differently these days with riding a Russian rocket for the most part, but we do have some new vehicles under development, and I wanted to help get part of that word out there because y'all know space shuttles, those were around for several decades, but we're doing things a little bit differently now, and still an exciting program, but it's a little bit different, and folks, it's good to have folks understand what that is. Our astronaut office in NASA is a pretty diverse group, a combination of women and men, pilots, scientists, all the way to educator astronauts. We have 2 teachers currently in the office that try to do their best to make sure that the message and the teaching opportunities from space are kind of out there throughout the range of education that folks go through. These are both shuttle crews that flew into space back in the late 2000s, a nice diverse group of folks there. This last year, in 2013, we hired 8 new astronauts, and the reason I think that's important for you to know is that it's not that we're closing down the program in Houston because the space shuttle is retired. We actually need to continue to hire new astronauts to continue to fly and operate the International Space Station on those Russian rockets. I guess you probably all know most of what we do in the big pictures where you see folks launching on rockets and getting into space. There's a fair amount of work that happens on board the space station that is a little bit less glamorous than wearing an orange suit and sitting on the pointy end of a Roman candle. You can see TJ Creamer here's on the bottom right. He's actually storing samples, so that's why it's kind of foggy there in a minus 80 degree Fahrenheit refrigerator that we protect all the blood samples and other things that are collected on board the International Space Station. So that's an example of some science that's going on board. This is a crew, Mike Fink and Greg Chamitoff, who are actually installing something with the robotic manipulation system. So these guys' hands on 2 controllers. Most of the cargo vehicles that come up on the U.S. side actually get close to the space station, and the crew reaches out and grabs them, installs them on the space station, and that's the kind of thing that those guys are doing on board. So resupply, so science, resupply. That's a picture of a Soyuz and a shuttle, kind of how folks get back and forth to the space station. Right now, the way we execute at the International Space Station is with crews of 6 people on board at any given time. 4 U.S. crew members a year, 1 on each of those Soyuz rockets. This is a Soyuz rocket getting ready to launch out of Baikonur, Kazakhstan. Of course, this is what it looks like when it's going uphill, goes to space station, stays for 6 months, and then lands, nice flat place in Kazakhstan. We plan to do that until 2017, at which point we're hoping to transition to a U.S. vehicle, a U.S. capability to launch folks into space. Any questions just in general before I continue on here with space station operations? You'll understand a little bit about. Go ahead.
What's the stage of the Russian development for the successor to that launch?
The Russians actually are really not going to continue with a development of this vehicle into anything else. And so it's had a series of kind of incremental upgrades, so they made it a little bit bigger so they could take a wider range size of astronauts. Originally, all the astronauts, or at least cosmonauts, were 5'6" and 140 pounds, and so they've expanded it out so that we get a little bit wider range of the population, if you will, that can make it into space. So, and as Americans, we appreciate having a little bit more volume. They've also upgraded a lot of the analog systems that were in that Soyuz capsule. So, many years ago, it was all analog electronics. They've upgraded it to a much more digital control suite, a lot more computation power. The crew has more insight. Instead of just one point that they could land at, they actually have a series of computed landing points that they could select from if there was an emergency of some sort. So, more computation power, little incremental upgrades. They don't plan to completely replace that vehicle. It's worked pretty well since the 60s, and that's the way the Russians do business. So, yes, sir?
Because of the dust hitting the surface, is that vehicle spherical shape?
This vehicle is kind of the shape of a gumdrop. Okay, so it is round, but it's shaped like a gumdrop, if that makes sense. It does, and they typically try to avoid really, really windy conditions that would put them into that sort of a situation. Typically, the chute does a good job of collapsing. Sometimes when they do touch down, it's less of a drag and more of a falling over. If you touch down at a little bit of an angle, that surface is really hard when it's dried out, and they want it to be not too soft. And that you can be in a situation where your kind of CG's a little bit left or right and you actually roll over. So you touch down, chute collapses, and then the capsule falls over a little bit. Crew's all strapped in, so it's not a big deal for them. Yes, sir, in the back.
Could you explain, please, the single one-year mission in 2015?
Yeah, that's a good point. So what we've got on the books right now is typically 6-month missions. We are going to try something a little bit different in 2015, where we ask one U.S. crew member and one Russian crew member to stay on board the International Space Station for a year. Now, that's been done before. The Russians have done it several times with crew members that have been on board the space station Mir for greater than a year. When all that was done, though, we didn't have the medical capability to really monitor the crew members' health. We kind of got that cosmonaut into space, brought them back, and then measured how big their calves were with the tape measure and that sort of thing to see how the space environment had affected them. Now we have ultrasound equipment, EKGs, all that stuff happening real time, sample return, blood, urine, otherwise coming down on those folks. So we'll be able to monitor their 1 year in space really carefully. And the reason folks think that's important is that we have a lot of data that suggests that the human body adapts over the 6 months that you're in space to something pretty stable. The question is there something at the 8-month or 9-month or 10-month point that we just don't understand? And so there are some phenomena I'll get into a little bit later, eye changes and things like that, that it would be important to know if you were ever going to go to Mars or further out or want to be in space for longer than just 6 months. Okay. See, I'm going to go ahead and jump forward here. Okay, I put this chart up here not because I want you to read it and memorize it and have a test over it. But that might be a good idea if this was a pop quiz or something from back in the day. But what I wanted you to see is that in order to execute the space station program, there's a lot of moving parts. There's a lot of stuff going on. So what this shows up here at the top is kind of the rotation of crews. Each one of these band of 3 is one Soyuz, another Soyuz, another Soyuz, another Soyuz. They overlap at times. This is the crew that I'm going to go pick up out of Kazakhstan next week. When I head over, they'll come back on November 11th, and I'll bring them home to Houston. This shows all the ports on board the space station, how we have to move vehicle to another docking port, to another docking port whenever it jumps across here. That's a lot of stuff going on. Each one of these little people that you see there, those figurines, those show spacewalks that are going to happen on board the space station to keep it going. These are all U.S. vehicles that are coming back and forth to the space station, so you can see each different color is another vehicle. These are all the rocket launches. Every one of those pointy sticks is a rocket launch with a date that it takes to resupply and keep the space station operating. So this is not just, hey, one Soyuz goes up every quarter and changes out the crew. This is a lot of rockets going to space station. It's a busy place, vehicles coming and going every week or two with new supplies or new experiments or samples that need to come back to Earth. And spacewalks to kind of keep everything moving as well. Now, if you're a crew member, you don't look at a chart like this and see all that stuff going on. You care about where your seat in line is on this space station. And so I put this chart up there to show you that we do have a plan here where we would transition from the Soyuz operations, where we go uphill on 3 people on 1 vehicle. We've got a development vehicle scheduled to launch to the station in 2017. And then we'll start transitioning to a U.S. vehicle that provides a capability to get 4 people on our vehicle to station versus the 3 that the Russians have. Okay, of those vehicles that are headed towards space station, we've got 3 companies right now that are under development. Boeing is one of those companies. I think most of the work is not necessarily happening in St. Louis. It's happening down in the Houston area or some other facilities, or at KSC where they're starting to integrate things. You may have heard of the SpaceX company out in Southern California that has actually sent a cargo ship to the International Space Station a couple times recently. They plan to modify that to turn it into a crewed vehicle. And then Sierra Nevada Corporation, they had a drop test this last weekend of a lifting body where they landed on a runway out at Edwards Air Force Base, and I was out there for that. So one of these 3 vehicles, maybe 2, will be selected next fall to go into production for us to start flying a U.S. Crew members to space on our own vehicle. Okay. Any questions about kind of the big? Yes, sir. So they all have reusable components, and it's, I think what we learned a little bit from the space shuttle days was that, hey, you can reuse the whole ship, and if you reuse the whole ship, that can be really expensive. If you reuse pieces and parts, a computer, for example, that may get some radiation exposure while it's in space, but doesn't go through a lot of thermal transients, if you do the right checkout of it when you get back, you might be able to swap that computer into a new vehicle. I personally like a new heat shield. I like for that to not be something that... not to be something that you keep reusing. Although they tell me there's enough margin even in the Apollo designs to actually do 3 or 4 re-entries from the moon with the heat shield that they built. I don't want to necessarily be the crash test dummy on the 3rd or 4th heat shield coming in. So I would prefer a new heat shield. So it makes sense to use the right components, the capabilities for non-destructive inspection that we can do, kind of dictate, hey, it makes sense to evaluate this hardware for reflight and maybe replace this other piece of hardware. So they all have different components that are along those lines. You can imagine a lifting body like this, they'll want to reuse a fair amount of actuators and things like that. It's complicated. Something that's more like just a pressure vessel, you might that might be a little bit easier to just replace the pressure vessel itself. Yes, sir.
Do you take special effort since you're together for 6 months to match cosmonauts psychological musical taste?
It's a very good question. I think it was harder back in the days when we had just 2 or 3 astronauts or cosmonaut combinations on board the space station. It was harder when we didn't have the capability to have phone calls from the space station regularly. We had crew members that's primary contact back to the English-speaking voice, for example, on Mir was a ham radio. Now, those of you who've operated a ham radio know that trying to reach your spouse the day that somebody's got a major event at grade school or something via ham radio is probably not a good solid plan. So the folks now have pretty good contact. We have every week the capability to do a video conference with your family, for example. Every day, multiple times a day, you can pick up the phone and do a voice over IP telephone call and talk back to your family, and that goes a long way to making folks feel more comfortable. So we do take care. I mostly focus on making sure my 3 U.S. folks are good and a good solid crew. I don't have as much control over picking the cosmonauts, but I do have the capability of influencing the Europeans or the Japanese to make sure it's a good match on the U.S. side. And then if the Russians do the same thing as a group, they've got 3 good folks, we got 3 good folks, it'll be a good group of 6. And so, okay, there was another question in the back there. Yeah, it's a really good question, and I think the Sierra Nevada Corporation is trying to sort that out right now. It's got a lot of composite features, and so it's just been too soon to actually get the inspections complete to understand. Now, the vehicle, in some sense, skidded off the runway at low speed. It didn't smash into the ground. It came down in a very controlled fashion. The aerodynamics all worked really well. When it touched down on the runway, though, it did roll over and skid off of the runway with that main gear problem. So since it wasn't an impact, there's hope that the damage won't be too severe. But it will take, I would expect, several weeks before they'll have the NDE back to know whether it's reused. Their plan is to, I think, to reuse that vehicle in future upcoming tests that they've got. And so they'll have to assess whether or not that impacts their schedule. I think this is not a technical hurdle. It's more of a, hey, how quickly can we rebuild this one piece? They weren't testing the landing gear necessarily on this test. That was just a kind of a test artifact. They were testing the aerodynamics, which worked really well. One more, and then I'll keep moving.
I recently read Lovell's book on Apollo 13 and how that orbiting craft had to rotate 360 degrees. Does the space station rotate also in its Earth orbit?
So the space station, of course, does have a lot more capability, I think, than some of the early vehicles that were kind of fixed. All of these solar arrays rotate to track the sun, and they rotate in a couple of different axes. They can rotate about this axis individually, and then as a group, they can kind of rotate as a large group. And we can do all of those arrays independently. And so that's usually the driver for needing to rotate a spacecraft is to keep the solar arrays pointed at the sun. The space station kind of flies kind of in the same attitude around the space station, and the solar arrays do the tracking versus the space station having to do the tracking. Now, in addition to that, there are thermal radiators that you don't really see that are kind of on the backside here that also have to track. There are heating considerations. If you have too much sunlight on different portions of the space station that don't have active cooling, you may have to manage that with a whole bunch of temperature stuff. But those are typically slews in attitude, not tracking as you go around the Earth. Is that answer for your? Okay. Let's see. Where was I? So Sierra Nevada Corporation. So I put some slides in here on the vehicle for other destinations. And so I pointed out the Boeing, SpaceX, and Sierra Nevada Corporation vehicles that will come up and potentially do a rotation of space station crew members. We also have a program NASA does to develop a crew capsule and a launch vehicle to do exploration class missions. And we say exploration class, we mean not low Earth orbit. We mean going back around the moon. The moon is not low Earth orbit, it's exploration class. You don't have the capability to get back to the Earth in 90 minutes. You need days in order to make it back to the Earth. That's where we start transitioning to exploration class. Now, those vehicles require some sort of a design reference mission so you know how big to make them, what sort of supplies, what sort of velocity change capability you need with them. And so there's been a series of missions that have been floated out there to make sure that these vehicles are capable of doing a wide range of things. There's a proposal to actually take an asteroid that's further out and actually bring it back to the Earth-Moon system and put it into orbit with us and then visit that. There's also some proposals to potentially put telescopes or other things at Earth-Moon equilibrium points and then service or visit with the Orion and SLS. And so those design reference missions, I try to emphasize to folks to not get locked into, hey, where is your destination with this specific vehicle, and we're going to point design just for that. Because everything that we've done spacecraft-wise, Space Shuttle, for example, building the space station and all the missions that it ended up executing, it wasn't necessarily designed from the get-go to do all those things. The spacesuit that I took out to service the space station 6 different times was not designed with that purpose in mind. It was designed to fix the space shuttle if it was broke so you could get it back to the ground. It wasn't designed for necessarily 8 hours of a continued maintenance exterior on the International Space Station. So we think of these reference missions as capabilities, and if you can meet those capabilities, you can do all of these sorts of missions. And so when folks get locked in, I don't like the technical detail of asteroid retrieval. I don't like the equilibrium point that you've selected to go to. What you need to think about, and from an engineering system, if you want to have the capability to go anywhere, you need to lay some of these design reference missions out and then build a vehicle that can do a wide range of them, and that's what we're trying to do here. Okay? This is that Orion spacecraft vehicle. It's an old Apollo-style shape. So it means it doesn't land on a runway, but it also means that you can land most places on Earth, because most places on Earth don't have a runway. So it's a good idea to have some capability that doesn't require a runway. All these pieces of the system are under development right now. Launch abort system's got some testing. They powered up the service module at the Kennedy Space Center just this last week or so. And we got a service module component that's in partnership with the European Space Agency. These are more just adapters and things to connect it to the launch system that'll get it into space. Go ahead, sir.
Help me out here. How is this different than the Apollo program from the 60s?
How is it different from the Apollo program from the 60s? It's a bigger vehicle, and it also, we don't have the Apollo program from the 60s, so this exists and that doesn't, I guess, is kind of the...
So let me understand a little better here. So you're designing a vehicle, again, that we designed in the 60s?
We are designing a vehicle with capabilities that match up to something that we could do in the 60s, that's correct. Yep. There is a booster system called the SLS. Now, it's a good point that, hey, is this going to be the same thing that you did back in the Apollo days? Now, the challenge is we just don't have Apollo anymore. So if you want to go do exploration class missions, if you want to go to these locations, you do need to have that rocket, which we just don't have anymore. The booster system is also under development. It won't be the Saturn V. It will be a derivative of the shuttle launch system that we had as part of the Space Shuttle program. Okay, with that, before I shift into just more kind of nuts and bolts of what it's like to go on a space station mission itself, I wanted to see if there were any questions, at least in terms of what the direction that NASA was headed here with these vehicles and headed to space station. So, yes, ma'am. I think that the big thing for us is these 3 vehicles. And so folks look at our budget situation in the U.S. and they say, hey, we don't have funding for anything. And we look at these projects that are buying bond funds, for example, the quantitative easing and things like that. The scale of the purchases that are being made with those funds are so large compared to what we're asking to do here. It's a bit of a distraction and kind of comparison. But folks look at this and say, hey, if we're doing all those things, we can't afford this little bit on the margin. I'll tell you that the investment long term that you're avoiding doing and not continuing to invest in infrastructure or research and development or capability will set you back decades in the long run versus the short run. So I think the situation we're in is that people have so many tactical urgent needs right now that we're cutting off all of our strategic goals for downstream. So that's the situation we're in. Year to year, these programs all get cut to the point that each time you cut them, they delay a year. We're to the point that each budget that doesn't come through, it's another year that we're paying the Russians to get our folks into low Earth orbit. Yes, sir?
And one more question. Let's see, based on what you've shown here, I mean, this looks like things like hypersonics are basically not of interest to NASA anymore. Would you say that's true?
Well, I think what I'm presenting is kind of a flight crew operations piece of NASA. There's a wide spectrum of that we're in probably the 20% of NASA's budget sort of thing. There is a large hypersonics effort that is going on the West Coast, and we have launched in combination with the U.S. Air Force some hypersonic vehicles, and that is definitely of interest to NASA. It's just not our way to get to space station. Hypersonics, those
I see that in the near term, hypersonic manned vehicles, geospace orbit, those kind of things coming around.
In the near term, our way to get to space station by 2017 and to get into low Earth orbit by 2017 is going to be on a solid rocket booster that's going to take one of these sorts of vehicles up. Now, the hypersonics work is right now not focusing on getting all the way into low Earth orbit. It's focused on a rapid deployment sort of capability and has more military applications right now, I think, from our perspective. I'm not trying to get my astronauts back from Kazakhstan to the U.S. really quickly, but the DoD might want to get something to Kazakhstan really quickly. So, so it's just a little bit different focus. NASA is definitely a big part of that, but just not the manned portion of NASA. Yes, sir.
Are the, especially with the new U.S. vehicles, I guess, one, do astronauts still do any training in Russia? And two, if we're using just U.S. vehicles, will they move all to the U.S.?
It's a good question, and on the International Space Station, let's see, we anticipate continuing to take every vehicle that goes up with us, a Russian or a European on that vehicle. So when I put this chart up here, there's a lot of detail on it that I'm sure you would have no way to know this, but these pink lines indicate Russians, the blue lines indicate U.S., all the other colors indicate Europeans or Japanese or Canadians or indeterminate international partners at this point. So if you look down here, when we transition to our U.S. vehicle, we have a continuous line of Russians on our vehicle, and we keep a continuous line of U.S. folks on their vehicle. And the reason for that is, as a specialist operating their portion of the Russian segment, we don't want to put the effort into teaching our person to be level 4 language qualified in Russian so that they understand the bolts. We actually have the engineers, the cosmonauts in many cases are engineers from Energia and Roscosmos who built that portion of the space station. So rather than turning our folks into Roscosmos and Energia engineers, what we do is take one of them with us and they take one of us with them is the plan. So our folks will continue to train still for emergency procedures, just not that high level of nuts and bolts detail of schematics of how to operate the space station, more how to save yourself in an emergency and get the Russian combat so you can ask the right specialist. Any other? Yes, sir.
I was just going to ask before you move on to the next level of detail on the crew operations side is you touched on the broader budget of NASA. I just thought maybe a few minutes on what's the broader mission and what are some of the other programs going on in parallel.
So I guess the harder part for me is to answer questions about all the other budgets that are out there. I do know NASA continues to have a kind of a robust effort to do robotics exploration. The astronaut office is not necessarily a big part of that, but I'm sure you've seen the Jet Propulsion Laboratory rovers and other activities that have headed out to Mars. There's definitely a large effort to go in that direction. And I think in the future, we'll have more and more combined operation activities. So on the space station side, we have a fair amount of stuff that is actually robotically done. It's just put in place and set up and then left alone by the astronauts while the ground operates it telerobotically or to collect different scientific objectives. So we have X-ray observatories, we have telescope capability, we have satellite deployment, we have refueling operations. All those are happening on board the space station telerobotically in preparation, precursor-wise, to sample gathering or otherwise that might occur in the future on Mars. We're just we're kind of along for the ride, or we set it up and facilitate those robotics operations. I can't really speak to the size of their budgets or the specific scientific objectives that they've got necessarily, but I think it's important that we work together to do those things and not say, hey, we have a manned piece and we have a robotic piece. It's going to take the combination of both in order to accomplish anything. So, yes, ma'am.
Is there a common language used on the space station?
It's a good question. The common language on the space station is English. By agreement and written down in paper that's how it will be. In practice, it's a combination of Russian and English. Our crew members speak enough Russian. I had to study a fair amount. I lived in Moscow for 6 weeks with a family in an immersion program so that I could get by with my Russian, I guess. In an emergency situation, I would hear the radio. The Russian control center speaks Russian to the crew. The U.S., European, and Japanese control centers all speak English up to the crew. Typically, we have a native speaker hearing on the other end of one of the two languages. On board the space station, it ends up getting a little bit more muddied, but okay. Yes, sir.
The space station now has been up there for several years now, and we hear that all kinds of experiments have been done. Could you just talk to what have we learned that is useful for us?
Yeah, unfortunately, I put my slides on the science in my afternoon presentation, so I don't have them embedded in this presentation. But just on the list of things, I think the primary focus, I'm going to jump all the way to the end here and show you a chart, and then we'll come back. Why don't we wait till the end, and we'll talk about that at the end, because I do have a chart at the end. I don't want to steal the thunder of all these other photos by getting to that point first. So how about I do that at the end, and when I got one chart that summarizes kind of things we have learned and our burn-off rate for learning the rest of the things we need to do for future exploration missions. Okay? Yes, sir.
Is there any prospect, in your opinion, for any joint activities with the Chinese?
So NASA's in an interesting position where we do what Congress says, and which is what most of the government is supposed to do, or at least what Congress pays for. We try to take care of. We try to do what the president says, but what Congress pays for, which puts you in a little bit of a pickle sometimes. In our situation, we are directed not to work directly with the Chinese, and so we don't have astronauts that are going over to ride on their rockets. We don't have Chinese that are coming to train on the International Space Station. That day is probably coming where that bridge is made, because our Russian colleagues are already working with the Chinese. Our European colleagues are already working with the Chinese. Our administrator recently visited China for the second time on a fact-finding or discussion, high-level interaction sort of a meeting. But we are directed specifically to not cooperate, I guess, directly with the Chinese government. So, okay. Yes, ma'am. Yes, sir.
I read that the Orion project is going to Mars. Is that true? And if it is,
I remember I mentioned a little bit earlier that for that Orion vehicle, it's going to be able to go to a lot of different places. Mars is potentially one of those destinations. The first Orion capsule that's built won't go to Mars. We'll have to do some things before we jump all the way to Mars. So I would expect by the time we get humans headed towards Mars, you'll be old enough to be standing up here telling me about how you did it. That's maybe your future, is to. I'm sorry for that. That's maybe your future, to head towards the International Space Station for one mission, and then ride an Orion rocket ship off to Mars or to some other destination out there. So 2030, so let's see, if you add 20 years to your life, that would be right prime time for an astronaut career. Okay? I'm going to switch gears. Yes, sir.
This deals with the budget and how NASA's going to afford all these things. Usually you keep talking about we're going to turn these launches over to the private industry. And I wonder how you interpret that when they say turn it over to private industry, because I think during the whole NASA existence, private industry really has built all these things and launched them, and so you envision that NASA is going to try to get out of the nuts and bolts of actually doing all the launches and maybe cut down the cost?
I think we'll be in a situation where there's a transition. It's not going to be black or white. It's not going to be a case where NASA no longer participates in any of the launch activities, or NASA no longer participates in getting those crew members to space. As long as our folks are riding on that rocket, we need to have the insight to understand how things are progressing, because when the phone rings from the White House or from the NASA administrator, he's not going to call Elon Musk up to talk about how the crew's going to do. He's going to call me. And so I need to have that insight in how things are going. And I anticipate that's going to be true kind of across the board. It is a bit of a misnomer, in my opinion, this idea that commercial partners weren't part of every rocket ship that we've ever built. All of us that watched Apollo 13 can probably remember the scene where the flight director says, hey, I don't know what it was tested to do. I want to know what it can do. And he's talking to a Rockwell engineer who's telling him how the vehicle was built. He's not talking to a NASA guy who's telling him that. He's talking to a Rockwell engineer about what that vehicle can do to safely bring that crew back. So I anticipate us being in that similar sort of a situation. It may be a smaller footprint. The number of NASA folks that are involved in the process might be a little bit smaller, but the commercial companies built all of our previous rocket ships. This avionics on that space shuttle came from Rockwell. They didn't come from a NASA lab at Johnson Space Center. The United USA company, a combination of kind of Boeing and Lockheed together, did all the servicing and maintenance on that space shuttle. These solid rocket boosters came from ATK out in Salt Lake City area. So all the pieces of this vehicle were built by companies, and we launched it into space and we wrote it. NASA kind of operated it, and I anticipate us being in a little bit more of that operator role. Again, it's a misnomer, I think, to call those not commercial partners.
I think that was kind of a smokescreen that they were going to reduce the budget by having private industry do it. They have been doing it.
But on a weekly basis, if not, and it will transition to a daily basis over the next year, I talked to Boeing, I talked to Sierra Nevada Corporation, I talked to the SpaceX folks about how we're going to have that handshake between us. They want our help, they need our help. We have flight directors from the Johnson Space Center that are on contract with Boeing to provide insight and help in the construction of their vehicle. SpaceX wants my guys in their capsule to give them the evaluation for how they're progressing and what they should do differently. I was at the drop test for the Sierra Nevada Corporation test that happened this last weekend. So it's not that NASA's not involved. Yep. Yes, sir. Now I'll move on.
What kind of metals do you put on spaceships to help it on the hull to help it from burning up and re-entry?
It's a good question, and we have some metals that are on the outside of a spacecraft, and they're typically really heavy metals that can take a lot of temperature, like might be in a turbine blade inside of a jet engine. So they're made of nickel, really heavy metal, and also titanium is a really light metal that has some good temperature properties that we involve our vehicles. But from a heat shield perspective, I want you to look at all the outside of this. This external tank that's orange that provided the fuel for the space shuttle, it was built out of aluminum, so it would be really light, but then we coated it with a whole bunch of insulation so that insulation would be what protected the coolant that was there while this rocket went uphill. So we used a cheap metal, relatively, one that wasn't too fancy, but we put a good insulator on the outside of it that wasn't metal to make it work out. The outside of the space shuttle itself actually has almost zero metal on it. It's all materials that can heat up really high, like your cookware. You know, your mom might have a crock pot or some ceramics that can go in the oven, and those can go really hot. That's kind of the materials that we might have on the outside of the space shuttle. So we try to avoid metal. We try to use some other things that more like brick or that sort of thing, light bricks, if you will. Okay, I'm going to jump through just a quick set of slides here that just talk about what it's like to kind of go on a mission. And the details aren't important, like what kind of rocket is this? This is a space shuttle, or a Soyuz that somebody else might ride, or one of these commercial vehicles. The point is that there's a life-changing event that occurs that gets you into low Earth orbit, and it's a rocket that makes that happen. So this is my launch out of the Kennedy Space Center a few years ago. You typically head straight towards a space station these days. It took me 2 days to get there on board a space shuttle. The crews now on the Soyuz are getting there in about 6.5 hours. They're doing a 4-orbit rendezvous. They ground up rendezvous. They do a couple of burns. It's very expensive if you were a space shuttle and you were really big. Soyuz is small, so you can make that work out. And so rather than spending 2 days feeling a little bit nauseous while they try to point those solar arrays right at the sun, you get to go straight to space station where the solar arrays move instead of you, and the folks really, the crews really enjoy that. Everybody does their obligatory Superman pose when they go through there, and this was mine from one of my missions. Typically, throughout the mission, you'll have kind of some high-value activities, at least from a memories perspective. After a while, turning experiments on and off and things like that is very rewarding if you're the principal investigator who's collecting the data and actually seeing it resolved. But that's happening on the ground for the most part for our folks. They're collecting all that data. They aren't putting it in an Excel spreadsheet and making a PostScript file out of it for presentation at a conference. Somebody else is discovering the wonderful things that came out of that data. They're just the hands that are making that data get collected. High-value things for us are our spacewalks. Those are the ones that operationally are challenging and also very memorable because it's a different experience for you. You typically don't get to do very many of them. This is me and my partner on one of the spacewalks, actually installing some new cooling lines for a new module. This was a Node 3, the habitation module, if you will, on board the space station that we took up and then outfitted with electricity and cooling. Of course, you do have some time to kind of hang around, and this was me wearing my T-shirt from space, my Washington University T-shirt in space. So you get to take a couple of photos like this over the 6 months that you're there. Sometimes the president calls you, and that's me over here, and he called and asked us some questions with a group of school kids similar to this sort of an audience, maybe easier questions than some of the ones I've gotten today, but from the presidential side at least, but or the school. I'm not making a political statement, but just he's got a group of school kids there, so he tries not to ask me the hard questions when we're in that situation. Let's see, at some point, everybody, whether it's on a space shuttle or on a Soyuz, undocks from the space station. And I'll tell you that this, for most of us, is a very emotional experience. So you trained for years to get to that space station. You trained for years to execute all the things that you were asked to execute, whether it was a payload, robotics operations, or spacewalk. You trained for years to execute all those things. And what this means is that's over, right? You're waving goodbye to that place that you were headed towards. So it's a pretty emotional experience for most of the folks. You usually take a minute to look out the back window or whatever of the vehicle that you're on and wave at the space station and take a mental note of what it looked like, so when you head back at someday, it'll be there waiting for you. So you all have to come back down and touch down at some point. This was a touchdown for me on a runway at the Kennedy Space Center. I showed you a little bit earlier the steppes of Kazakhstan where Soyuz is touched down on. Again, the important part of this is not that what vehicle that you came down on. It's the important part that this is a life-changing event as well. You're all the way back to Mother Earth. You're not in low Earth orbit anymore, and it's definitely a big relaxation. I don't know how to describe the sense of burden that comes off of your shoulders when you step out of the space shuttle in your next action. You know, they often describe astronauts as the one person who can make anything worse with one switch throw. You know, you're in space, all it takes is you doing one switch throw, and you can make things a lot worse than they already were. that burden comes off your shoulders when you climb out of that rocket ship. And it's a welcome relief after, whether it's 2 weeks or 6 months or whatever, or 1 year for Scott Kelly and Misha Kononenko, who are coming up here on their mission. Okay. Let's see, and after your flight, you get to go and talk to the president again, and which was a kind of neat experience for us. It's interesting, this picture makes me look way bigger than the president, but the president's way bigger than me, just that this is some sort of a fisheye lens here that they've got going on. So, but that was a neat experience. He was very gracious and took time out of a rose garden activity that he had to shake our hands and talk some about our mission. So with that, I always put this up there. This came from Space Day, May 4th, 2000. I was selected as an astronaut in July of 2000, and so I had seen this picture, and it was a neat thing for me. And Lockheed Martin was the commercial partner that was supporting all these activities, not NASA doing all these sorts of things. We were in combination with a commercial partner. And I've always liked this photo, so I always put it in every one of my presentations. Let's see. I want to see if there's any questions back on this photo before I jump to the gentleman's question at the end to talk about the science burn-off. Yes, sir.
Maybe anatomical or theoretical, but after all your time in space, doesn't time go slower and therefore how much younger are you?
It is true. Being a physics undergraduate, I remember having to do all those special relativity computations, and it is true that the crews on orbit are slightly younger when they come back, but we just aren't going fast enough, particularly relative to the Earth, to make that much of a difference or anything noticeable. So fractions of a fraction of a second is how much younger we are. So we got a guy named Ed Liu who recently moved on from Google. He left the astronaut office and went out to Google, but that was he wrote a paper at some point about how small the difference was during his time on orbit. He wrote the paper and then published it when he got back. So, yes, ma'am, in the back. That's a good question, and that Orion capsule potentially was designed in one of its variants, one of the design reference missions, to actually dock with a vehicle that would be a descent module to head down to the lunar surface. And it's a question of, do we want to build that habitat? I mean, that takes Congress telling us to build that habitat on the moon and us being able to go forward with it. So we're at NASA very much the executors of what Congress tells us to go off and execute, or what the president tells us to go off and execute. And when they tell us to build a habitat on the moon, we'll build a habitat on the moon. When President Kennedy told NASA to go into low Earth orbit and put a man on the moon, they did it, and they just, Congress funded it, and it made it happen. And that just takes a decision for us to go and do those sorts of things. Yes, sir. I think I understood the question. Is there a possibility to live on the moon? And what was the next piece?
I'm talking about over 5 years.
Okay.
Could we use the moon as a place that people can live? The folks that we feel that we
I think the possibility to expand our population from the Earth's surface to the moon is definitely possible. The challenge is how expensive it is. And so right now, I showed you all those rocket launches that it takes to populate the International Space Station with the supplies that it takes to take care of our crew members. It would, at least initially, take a lot of supplies to populate the moon with the capability of producing food and things like that for a large number of people. So until you can, I'll use the word terraform, until you can make the earth grow crops and support animals or otherwise that provides food, oxygen, water, and all those things for humans, it's going to be prohibitively expensive to have more than just maybe less than 10 people living on the moon or less than 10 people living on a space station or Mars or wherever you put it. It's just really, really expensive until that place supports life like the Earth does for us. So take care of the Earth, because there's not a good place to go other than Earth if you want to live there long term in our local vicinity. Yes, sir.
So I'll ask a more broad question, like a good question for the young guy on Mars, and then for living on the moon and whatnot. So for the young guys in the audience, assuming they study and listen to their teacher.
And their parents, they have to listen to their parents.
Anybody else? What do you foresee over the next 30, 50 years that the future will hold that maybe we're not thinking about today, such as what we do in the media with Mars and what have you? So what are the 2 or 3 things that you think could come to fruition over the next 30 to 50 years?
I think from a space exploration perspective, I would expect us to be doing much more combined operations between manned and robotic. Much more telepresence, if you will, both ways, whether it's a crew on orbit that's operating something that a person on the ground is getting all the data pipe, video, audio, sensory perception, all of those sorts of things to potentially operate from the ground as if they were actually in space. And so that transition will turn it into a case where somebody who's exploring Mars someday will be doing it from their desk with their eyes and their ears and their hands, feeding them that information while a robot or mechanical system or electronic system of some sort is moving across the surface of Mars or some other location. Most of the places that we can go are really boring most of the way to get there, right? It's the destination that's important. It's the destination of Mars, and that's where the fruition is going to come out. The years that it takes in the interim, I'll tell you what, the robot does that just as good as you or I do, certainly. And if we can get the data back and we don't need our complicated sensors and our complicated feelers, I think that's going to be the direction. That man-machine, woman-machine interface is going to be the breakthrough, if you will, from a space exploration perspective, much as it is for ocean exploration and things like that. Yes, ma'am.
When you had a mission that lasts 6 months, and now you're going to have one that lasts a year for those people, do they have to readjust to being on Earth at all after they land?
They certainly do have to readjust to being on Earth, both because of the gravity environment, but also psychologically for figuring out how to interact with your family again. I see it in folks because I arrive in Kazakhstan the minute they come out of the capsule. Instead of seeing just the maybe 5 other people that they saw on the space station, there's actually 50 to 100 people on the steppes of Kazakhstan, which is a new experience for the folks. They just haven't been around 100 people for quite some time. I do see people run up to them and try to shake their hand, and they want to move to the side. And they're not doing so good, so they move like this, and then it doesn't go so good for them. So if you ever see somebody who's come back recently, be ginger with them. Take your time, approach them slowly. Don't sneak up on them because they could hurt themselves being scared of you. But seriously, though, the physical aspects is still a big portion of that. One of the things we are learning for the space station is how to make it so our crews can come back as effective as possible. These Mars missions or otherwise that are postulated to be out there include a long transit time to get there, meaning a long period of debilitation, and then potentially a crash landing on a surface that you have to respond to. And so if you're can't move quickly because you've just been in space for 6 or 9 months in order to make it to Mars. We need to set those crews up for success when they actually get there. On my next landing in Kazakhstan, we'll actually take the crew members and walk through a battery of tests to evaluate operationally how can they respond in an emergency. Can they respond to a fire? Can they respond to a toxic atmosphere or depressurization, or climb out of the capsule and swim? Those sorts of, like you saw in the movie Gravity. Doesn't happen very often, but it did in the movie Gravity. So what type of response after being in space for a long period of time can you actually do is an important question that we're still trying to pull the answer together on. I'm going to go ahead and pop up this science slide because I don't want to miss this question. I'm not sure exactly, Libby, how much more time I've got here. So 5 or 10 minutes. So I wanted to switch gears a little bit just to show you a list of the things that we think we need to do in order to get to Mars. There's a whole list of tasks that started in fiscal year 2013, which is where we're at today. They started back over here someplace, but that's the past, and you're interested in the future. So the list of things that we need to work through, burn off all these science objectives to set us up for success if we head off to Mars. So each one of these things, I'm not going to go through all of them, but renal is actually kidney function and kidney stones and the generation of kidney stones. And can we safely send somebody into space for 6 months? Do we need to develop a countermeasure associated with that so that we're ready to go on longer missions without putting the crew member in difficult situations? DCS is decompression sickness. Because we do go through pressure changes based on going in and out of airlocks and things like that in ways that we don't normally expose people to in the zero gravity environment, moving elements or chemicals back and forth in your body that could potentially change, and we need to understand that before we put the crew members through these sorts of things. So those are easy ones. We got how you sleep in space, that's kind of taken care of. Now, in the yellow, things that we hope to burn off, and by burn off I mean have enough data collected so that we know how to protect our crew members from these issues when they go to Mars. We've got a current projected date for the end of the International Space Station on 2020. So the kind of science that we're working off, we worked off the kidney stuff, we worked off the decompression sickness, we've worked off some of these other things. We're still working off fracture risk. So your bone structure changes. We can keep the bone mass constant for folks that are on orbit. We used to not be able to do that. They used to go into space, they'd have a lot of bone loss when they came back, and we didn't know how to manage it. Now we can keep the bone loss to a minimum. The challenge is the structure of the bone. Apparently the way that it's being loaded in the microgravity environment compared to how it's loaded on Earth is causing structural long-term changes. That means people come back from space, 5 years later, 10 years later, they still have a structural difference. And we need to understand whether that means that they're going to all break their hips when they get a little bit older. And we have some anecdotal data that suggests, yes, that those structural changes are important. And we've had some long-term injuries associated with that for folks that you wouldn't predict would have those fractures. This is orthostatic intolerance and how we manage that when folks get back. That's a part of being able to respond after you land on Mars and you've got to get back to a gravity environment and have to do something in an emergency. Do you have enough blood volume or otherwise to make sure that you don't pass out when you try to do those sorts of things? Now these ones down in red are ones that we actually don't think we're going to get out of the red through the life of the International Space Station. One of them is how the muscles are adapting to the zero gravity environment, what the impacts of different food is, what's the right mix, protein, carbohydrates, or otherwise to keep crews healthy on orbit. VIP is one that's interesting to me. It doesn't mean anything to you guys, but it means vision impairment and interocular pressure. So we're sending our crew members into space. They're seeing increased levels of intracranial pressure to the point that their vision is changing. So the brain is squeezing their eyeballs out the front of their head, which is suboptimal, I think, if you want to stay in space for long enough. So that's something that, from my perspective, I don't like that to be red. I like that to be in the green category, and we're not going to get there between now and 2020, just with the variability of crew members, for example. There is some precursor work now based on blood tests and your body's ability to process different parts of the chemical chain that goes along with normal biological processes that might help us predict who was going to have a bigger impact from this vision impairment or this intracranial pressure. But we don't, even once we can predict who it is, that might be one way to get around it. We'd like to be able to prevent it in the people who do get it. And yes, sir.
Radiation exposure.
So radiation exposure is kind of wrapped up down here with cancer. And so it says, you can't see it, but it says 50% uncertainty reduction. And so our goal from a radiation perspective is to actually understand what increased risk of cancer or other, and it's not just cancer, radiation does other bad things to your body as well, but what the increased risk actually is from that radiation exposure. And that's something we don't understand right now, and that's something we're trying to work off. And it takes a combination of human subjects, animal research. It takes a lot a lot of different studies kind of coming together to understand how we get a better handle on what increased risk of cancer or cardiovascular impact or otherwise that radiation is causing. The mitigation plan, for the most part, with radiation is either shielding or trajectory management. So if when the Apollo crews went to the moon, there was a very careful trajectory management astrodynamics problem for figuring out how to transition the Van Allen belts in a way that minimized the crew's radiation exposure. I'll tell you that they did such a good job that our crew members that go to space station now actually get more radiation dose than those astronauts that went to the moon actually did. So, yes, sir.
On your chart there, we've got 6 or 7 more years of operation on the ISS. Is there a plan to replace that station? Or is there a plan for the next generation of low Earth orbit research?
The plan would be to extend the life of the space station out to 2028. That would be the desire. We've already put a lot of resources. I don't have the chart in here, but I do have a chart for the presentation later this afternoon that actually shows how much crew time, or we increased from 2 crew members to 3 crew members, and now we're up to 6 crew members. So we're in the heart of producing good science on the space station right now, and that just happened in the 2010 sort of a time frame. So we've kind of turned that corner. So now is when this chart used to be really stretched out. It used to be 2040 and everything stayed red. But now, since we've got 6-person crew, we're getting through more of the objectives by 2020, and the goal would be to space station, we think, can make it to 2028. It's a question of commitment on the U.S. side and our international partner side to keep it going. Okay, Libby's giving me the high sign here to tell me that I should wrap it up for you guys. I wanted to thank you guys for giving me the opportunity to talk to you some about this, and I appreciate the questions that came in. I know I don't have perfect answers for all of them, but I appreciate the questions nonetheless. And if there's anything else, I'd be happy to discuss it maybe after the brief or if we run into each other someplace else. So thank you very much for your attention.
Colonel Behnken has already answered a lot of questions. Thank you very much for this presentation. And I want to remind all of you that if you have some time in physics this afternoon at 4:30, I think, there's 4:15. Thank you, Marty. Bob will be giving another seminar. And tomorrow evening at the Founders Day, he'll be receiving the Distinguished Alumni Award of the university. So thank you very much, Colonel Behnken. Thank you all for coming and your support of Washington University.